Okay, good afternoon, everyone. This is a continuation from our correlation coefficient lecture. So, last time we talked about the formula for calculating the coefficient, which you need to be provided with the standard deviation and the mean. But this new formula here is important when you don't have the mean and standard deviation. So it looks complicated, but it's not that hard. It's easy. Okay, let's do an example. So from this example, you are given data x and data y, and you ask you to calculate the coefficient, correlation coefficient. So I think it's better if you create a table. So column x, and then you do the sum of x. Column y, do the sum of y. And because you multiply x and y, you need to multiply column x and column y, and you label xy. So you multiply the 2. 4 times 1, 4 times 2, more God, 7 times 3, more 21, and so on. So basically, the things here self understandable. So for example, the sum of x here would be this. You add up all these columns and you get sum of x. Sum of y, you add up all these columns, you get sum of y. N is the number of terms, which is 6, or the sample size. Okay, and as you can see here, we need to square the x, and we also need to square the y. So that's why I added column x squared, which is just a square of the values of x here. Same with y squared, which is just a square of this column, and I get this. And I also need to sum it up, because from this formula here, we need the square, sum of square x squared, which is this one. These two are not the same. This is the sum of x, which is this one, 21, and then you square it, which is different from this. This is the sum of x squared, which is this. And same with y and y squared. Okay, let's do the formula. So from this formula, label my pen. Then just up in our value. So we have our n is 6. Sum of xy from the table, that will be 211. Minus sum of x is 21. And sum of y is 48. And that's all over the square root. Yeah. So we do brackets. So n is 6. Sum of x squared is 91. Minus the sum of x and then squared. So that's 21 squared. Okay, another square bracket. So we have 6. Sum of y squared is 490. Is 48 squared. So if you compute all this using a calculator, you should get the numerator of 256 all over square root of 105 times 6, 36. Okay, for the calculations, you have 256 over 258.42. Therefore, our R is 0.990. And as you already know, if you're closer to 1, it's a strong positive correlation. Okay, so it's using this formula. It's using this formula to calculate without the values of what you call standard deviation and the mean. That's about it. Okay, so I have some activities here for you so you can try and do it by yourself. Exercise 1 and exercise 2. And here are some limitations of the correlation. So that's about it for us today. And if you have any questions, feel free to send me a message or come to my office. Some more activities for you to practice. These activities is up to you which formula to use. If you want to use the formula where you calculate the standard deviation and the mean separately, it's up to you. As long as you can find the answer. Okay, and that's your lecture for today. See you when I see you.